Hey, my name is Kristin, and today I will be talking about a physics lecture I attended. So this lecture was entitled "Seeing and Building with Atoms: Adventures in the Nano World." It was presented by Dr. Elisa Riedo. She is a lover of knowledge, a philosopher, as she started off her presentation by telling us. She then went on by telling us that everything around us is made of small particles named atoms. These are the building blocks of matter because nothing has been found that is smaller. To see and move these atoms, we must have something that is equally small. This is where scanning probe microscopes come in. There are two types, the scanning tunneling microscope, abbreviated STM, and the atomic force microscope, abbreviated AFM. The atomic force microscope has a tip that is the size of a single atom. You pull a ball with a spring to get it to move and jump from one atom to another. The jumps are all recorded using lasers. The scanning tunneling microscope works by using current. The current is measured, and depending on how much current is measured, the tip is lowered or raised. Now, how are these used? They can be used to pull two-stranded DNA apart to find defects. They can also be used to change the chemistry on surfaces. This is called thermochemical nanolithography. You heat up the tip, and the heated tip can be used like a pen. This makes a surface sticky, and you can use this to create patterns in different colors. Now, there's a video I'd like to show you that shows this very well. And as you can see, the pen is expelling the atoms, leaving a design on the surface. Now here are some examples. This is the Mini Lisa, which is 30 by 40 micrometers, and also that you can make fun shapes like pumpkins. Now some of the more prominent uses for this type of design are modifying semiconductor chips, writing patterns on chips to carry messages, and really anything that deals with altering the chemical makeup of a surface. Since technology is starting to get smaller and smaller, yet needs to hold more and more data, this process could be useful for inventing new technology. At some point, however, microelectronics will reach its limit. One more thing that thermochemical nanolithography can do is to fabricate piezoelectric nanowires. This means it can make nanowires that can be used to convert mechanical energy into electrical energy. This is useful so you could actually go for a run and be charging your iPod while running. Now, Dr. Riedo also brought up graphene, and I'll have a quick video that will show you that kind of describes what graphene is and who invented it, or found it, not invented.
Two Russian-born scientists shared this year's Nobel Prize in Physics for experiments with a substance they discovered in 2004 called graphene, the thinnest and strongest material on Earth. A layer of graphene is a single atom thick, so tiny it would take more than 1 million sheets stacked on top of each other to reach a single millimeter tall. But if you stretched a sheet of the carbon-based chicken wire-shaped material over a coffee cup, it would be strong enough to support the weight of a car. Scientists think that in the future, the wonder material could be used for high-capacity batteries, flat-screen TVs, and for ultra-small computer chips, its most promising use. And despite its amazing properties, graphene isn't rare. In fact, anytime you write with a graphite pencil, graphene is produced. That's how it was first isolated by prize winners Andre Geim and Konstantin Novoselov, who used Scotch tape to collect graphene from pencil lead, which just goes...
So this material will also be a boost in the nanotechnology world because of all these properties that they described. And lastly, I would like to leave you with a quote that Dr. Riedo left us with. Technology is a tool for your mind and not the opposite. Supercomputers will never be a philosopher, a lover of knowledge like we can be. Thank you for listening.